My name is Juan Marin. I work for Boundless, and today I'm going to be talking about geospatial data versioning. So I think we can all agree that history of your data is important. Events happen in time and in context, and there's always different versions of your geospatial information. I just put a couple examples here. This is a map of the former Yugoslavia, and now we have 6 countries, 6 different sovereign nations here. On the right-hand side, you see the effects of that war on ethnic distribution. So it's really important to keep track of these changes and to keep a history of your data sets. At the same time, we create versions of information not only for historical purposes, or not only because data changes over time. Sometimes we also want to compare different versions of information that happen concurrently. We may want to create different views of the same information, perhaps prove a point, or engage in some discussions with different versions of geospatial data. My argument is that we need better tools for this. Who doesn't want better tools, right? So this is the old way. The technical term for this is we have a big ass relational GIS database. They're cool, but this is what happens. Basically, you have a group of people working on a single version of the data, and then you'll have another group of people working on a different version of the data. And what happens is that guy is left wondering, how do I track some of those changes? How do I get some of your modifications, some of those are the guys' modifications, and work with that data? With this model, this is not possible. You have to go through all these hoops of checking back the data into the master version, and it's just not very convenient. So what if we thought about this in a different way? What if we had something like a peer-to-peer network of actors exchanging information, and they can exchange large modifications, but they can also maybe do it in a more atomic way. And of course, we all talk about the cloud. We love the cloud, so those guys in the middle are living the dream, right? So why is this better? Why is this model a better solution, better architecture? The first thing is, and it's really interesting how my talk latches on what some of the things that other people have said. It doesn't have a single point of failure. There's no central database that everyone has to go through to get information and versions of that information. The other one that I think is really the key of this approach is that there is no single source of truth for geospatial information, and this is really, really scary for the most traditional GIS people. But I'm going to argue that this is a good thing. You can still enforce authoritative data, but it's enforced by process, not limited by technology. That's kind of my argument. And these two things, the combination of these two aspects, is what makes it a lot easier to enable collaboration and sharing of geospatial information, and while we keep track of versions and data provenance and things like that. So we at Boundless have been working on this library called GeoGit. You can take a look at this at the website geogit.org. We just submitted the proposal for Location Tech recently. We're excited about that. And it's an open source project. We are actually already seeing people collaborating with us outside of Boundless, and we are also working with some of our partners in developing this technology. And it is a Java library that's released with a BSD license, so it's pretty commercially friendly as well. So the first thing that a lot of people ask, and I just want to get it out of the way so that we don't go back to this all over again, is why don't we use just GeoJSON and Git? And this is a good thing. If you can use this, go for it. But if you've tried using GitHub to store geospatial information, it's really, really limited. We tried this, by the way. Eddie is here. He's my boss. He has the 10 rules of life. I'm trying to imitate, he's a kind of a mentor. So I'm going to compile the 10 rules of open source. I only have the first one. The first rule of open source is don't reinvent the wheel, right? So we unless it's a square and it's not getting you anywhere. So Git is kind of a square wheel for versioning geospatial information. It doesn't work. There are many technical reasons for that. I'm happy to dive deeper with some of you if you're interested later. But basically, what it comes down to is that Git was designed to version text files, right? Not binary large objects. So we have a data size problem with that technology that ends up producing some limitations that I just, at least as a user, I can't live with. There are very, very stringent limitations on size. A GeoJSON file for the US counties, if you have the detailed shoreline, is about 200 megabytes, and that's a big text file. And that I would consider that a very basic GIS layer. It's not even a detail. It's not the level of information that we're talking about here today. Also, Git doesn't really produce a geospatial diff. A diff is the difference between two versions. It's how you present those differences to the user. And when you're working with Git and GeoJSON, you get a difference of the text that has changed. There's no geographic context there. And it also lacks some integration with the rest of the geospatial ecosystem. And by the way, I just want to clarify: I love Git and I love GeoJSON. It's just the right tool for the job. So, so what does a GeoGit workflow look like? In summary, it looks something like this. We have what we call the working tree. This is the kind of your working area where you modify your data sets. You're doing your editing with your tool of choice. And you add those changes to what we call a staging area and then commit them to the repository. The repository database is what keeps track of all the changes, all the history for your geospatial information. And there's a few operations that you see there. You add to the staging area. Those things are ready for committing to the repository. And then you can also do something that's really interesting, back to that slide, which is push and pull from remote repositories. So it has the capability to work with remotely hosted repositories through an HTTP endpoint. And that's what enables that kind of distribution of information. At that point, when you start doing that, data gets copied all over the place. And this is why I said there's no single source of truth, because basically you can create your own. And if someone allows you to clone the repository, you can take it and take it in different ways, as we'll see. So diving a little bit deeper into this concept, this is all enabled by the branching and merging workflows that Git has made really popular. GeoGit is not based on Git, like I mentioned, but it follows really, really closely the APIs and the same concepts, but applied to geospatial information. And in fact, we are treating vector geospatial data as source code in a way. So every time you want to make a modification, what you do, you have a main line of history. That's usually called a master branch. You can think of that as your canonical history of data. And every time you want to make a modification, you create a branch, and you're free to experiment on that branch with whatever changes you want to enforce. So it's really easy to isolate those changes from my canonical copy of my data and start working with that. And when I'm ready to bring it back, this is maybe after some QA. There could be actually several branches: an editing branch, a QA branch. At some point, you're ready to bring it back to master, and you just do what it's called a merge. And GeoGit will detect conflicts. If two people have modified the same polygon in different ways, you'll get the geometry differences back, and you can work with that and resolve those conflicts as needed. So why go through all this trouble, merging, branching, pull, push? There are kind of new concepts for geo people. I can think of many, many different ways and reasons why we want to do this, but I'm just going to throw in 4 today. So I'm going to talk about what-if scenarios, crowdsourcing, custom maps. I just want my own version of reality. And I'm also going to talk about OpenStreetMap, which is also like a good segue into or connection to the previous talks. So what if scenarios is, I guess most people know this, it's a very classical use case for geospatial information, for GIS basically. The idea is you have different alternatives of your data. For example, if you're building a highway, you might want to see the construction alternatives when you're assessing its environmental impact. Usually those versions of the road are discarded once the actual construction happens, but you might want to keep those around. Maybe there are some good ideas. Maybe you want to reassess some of those decisions, etc. So that's one of the areas where if you're doing some modeling and some analysis of the data, having different versions of your base data is really, really important. The next one is crowdsourcing. Everyone loves crowdsourcing these days, right? You want to leverage the power of the crowds or something like that. That sounds great, but at the same time, it can be dangerous, right? You don't want to expose your production database to whatever anonymous users are doing. But what if you have a branch out there that you expose and people can connect to that, they can ingest information, they can contribute, and then you have your own processes in your organization to perform a QA to decide if those changes are actually useful for you or not. So we see GeoGit as a tool that can help with some processes along these lines. Also, people just want to create their own version of information. They just want to create their own maps. So post-election US map. I have a little bit of for everyone, so there's nothing, right? And the French think we are Spanish people are flamenco dancers, which is not true. Just look at me. So anyway, why not, right? Just create your data. The next one that more seriously though now is OpenStreetMap. OpenStreetMap is a crowdsourced worldwide database of the street data. And most people actually use OpenStreetMap in a very limited way because what most people do is they create a base map, right? They create the tiles, they style them. You basically have a canvas on which to put your geospatial data on top of. And that's really useful. I think that's great. But what if you want to work with the OpenStreetMap data itself? And what if you want to bring it into your organization, version that, maybe filter it, and update that continuously? So GeoGit actually has a very good integration with OSM at this point. I'm not going to show a lot of code today or anything like that, but that's the command that you would use to actually download a section of OpenStreetMap by filtering with a bbox. It's very easy, even for people that are not used to command line tools. This is the greater London area, so that's what you would extract from OSM. And to keep it updated, that's the second command that you have to run periodically, every minute, every couple of minutes. And it will detect the changes that have happened in OSM, bring those changes back, and do a commit in your database. So you have your own version of change sets of OSM in your organization. Why would I do this? Well, one of the things that you can do with GeoGit is that you can filter that information and map it to your own schema. So if you're familiar with OSM, there's the schema is kind of simple, and then it gets tagged, but you have nodes and ways, and with the attributes associated with those, you can say, for example, like in this case, this is a data mapping file that says, I just want to extract the one-way streets that are highways. So let's say you want to have a version data set of highways in the US throughout time. This would be the combination of this data mapping file plus the two commands that I showed before would get you that basically into your repository. And of course, I mentioned this before. GeoGit has import-export capabilities from the typical data sources. We support shapefiles, PostGIS, Oracle Spatial, SQL Server. So you can extract that repository information to your spatial database of choice. You can also contribute to OSM. When you import a planet file, for example, let's say you make some changes to that because you're editing in your disconnected environment, and you can export those changes to a file that then can be uploaded to OSM. In this case, I'm exporting the changes that happened 3 versions from the current head. So I also have control over what section of changes I want to export as a change set. So right now, GeoGit still hasn't reached the 1.0 status. By that we mean that there might be some changes on the APIs, on the certainly on the internal structure of the code, but it is there's a command line interface implementation that's ready to be used. It is feature complete with that caveat. Nothing's ever finished. So, but you have a set of commands. You have a long list of commands that you can use. Some examples, and if you use Git on the command line, you're going to be right at home with GeoGit because the API looks exactly the same. So GeoGit log, it tells you the commits, a summary of the commits that someone has done on the repository. And I think this one is the interesting one, which is kind of the killer feature of GeoGit, which is the GeoGit diff. You pass 2 references to 2 versions, and it spits back a polygon. So that polygon changed. It gives you back the geometry that changed, and it tells you that it was. I don't know if it's here, but I think it's cut off. But it will tell you if it's an addition, a deletion, if it's an update, etc. We're not stopping here for sure. Things we're working on right now. We are working on a high-performance GeoGit server. We want to expose this functionality not only at the command line, but also as an HTTP server. I am not going to call it a REST API, but it's an HTTP endpoint with JSON and GeoJSON endpoints. Here you can see this is a GeoJSON of the features of a head. So you have a URL. You say, I want the current version of this data set, and it will spit back a GeoJSON. We're also working on, and this is part of the internal changes of the code base that I mentioned, being able to support large repository instances. So right now we've implemented support for MongoDB, but the GeoGit code base allows you to plug in different versions of key value stores. So we're really interested in maybe doing GeoMesa or Hadoop and things like that. And we're working also on performance optimizations of the code base itself. Many of the things that we do with GeoGit internally are kind of novel and very creative, and that means that there's a lot of opportunity for improvements on the performance in that sense. And also, we're not going to stop at the services level. We also want to go a step beyond and also provide user interfaces for casual users. And this is where we are done with our job, and we really the GeoGit technology will expand and hit the masses, right? I don't want people to learn how to do GeoGit init to create a repository, but I would like them to have a QGIS plugin where they just right-click on a folder and say, create a GeoGit repository, and have them work with versioning in that way and being able to push and pull from other people remotely. So here on the left, there's a screenshot of something we're playing with, which is the idea of scrolling bar where you can see the before and after of a particular commit. We want to extend that to comparing branches and seeing the differences. On the right-hand side, this is just a prototype for now, but these are actual working QGIS screenshots of, I don't know if you can see it very well, but there's a shaded corner of that polygon that has changed. So it'll show you that on a desktop client. And also the idea of, at some point, deciding what to do with the conflicts. Do I want to keep this version, that version? Do I want to go into an editing session so I can fix those things, etc.? So just to wrap it up, we believe this is a better model, basically, for the reasons that I said before. It doesn't have a single point of failure, and there's no single source of truth for geospatial data, which, again, is pretty scary for a lot of people, but it's good for collaboration. Thank you very much, and I'm happy to take questions if we have time or talk later.